Hello students, now we are going to see continuity equation of current. Continuity equation of current. To understand the continuity equation of current, we need to know surface integral concept and divergence. For this, we need to know surface integral and divergence. These two concepts we have discussed in first unit. With the help of surface integral, we can able to find flux from flux density, that is, while discussing electric flux, that is flux and flux density, flux is indicated with this symbol. Flux is obtained with surface integral of d dot ds. D is your flux density and ds is your differential surface. So by using the continuity equation or by using the surface integral, we are going to find continuity equation of the current. And by using surface integral, we can find current from current density, flux from flux density, and current from current density. Already we have seen what is the current density. Current density is equal to I by S, that is of current crossing perpendicular to the area. I by S, the units are your amperes per meter square, and current density is a vector. By using the surface integral, we can write I is equal to closed surface integral of j dot ds. So current is obtained from current density, where j is a current density. This equation is called as integral form of continuity equation. This is nothing but integral form of continuity equation. This is a integral form of continuity equation. As per the law of conservation of charge, it states that net outward charge must be balanced by decreasing the positive charge within the closed surface. What do you mean by it? Let us consider a surface. Let us consider a closed surface. There is a charge which is enclosed by the surface. This charge is outwarded. This charge is divergent. It is diverted, or there is a divergence. There is a positive divergence. So as per the conservation of charge, the net charge or net outward charge must be balanced by, this is the outward charge, this must be balanced by the decrease in positive charge within the closed surface, because there is no any source inside the surface. So outward should be is equal to the decrease in the charge, which is indicated with something like I is equal to surface integration of j dot ds. J dot ds is equal to minus dq I by dt. The here minus indicates a decrease in the charge. According to the divergence theorem, for example, if f is a vector, according to the divergence theorem, del dot f is equal to limit v tends to 0, that is of surface integration of f dot ds by v, that is your value. So by using this divergence theorem, we can write integration over, that is surface integration over s is equal to j dot ds. J dot ds can be written as the volume integration of del dot j into dv. This j dot ds can be written as minus d by dt of, that is qi, which is equal to minus d by dt of, but q is equal to, according to the volume charge density, rho v can be written as dq by dt. Rho v can be written as dq by dt. From this q can be written as dq is equal to rho v into dt. Then q is equal to integration over rho v into, sorry, it is dv, rho v into dv. So rho v is equal to dq by dv, dq is equal to rho v into dv, then q is equal to integration over rho v into dv. So here we can substitute that in the place of q we can write volume integration of volume charge density into dv. This dq by dt into qi is equal to, from this expression we can write it as a volume charge density del dot j into dv is equal to minus d by dt of volume charge density of rho v into dv. So if you equate these two, here you are going to get, this can be written as minus integration over volume integration over d rho v by dt into dv. So if you compare this and one and LHS and RHS part, we are going to get, in a place of del dot j, what we have here, d rho v by dt. So we can write del dot j. Del dot j is nothing but your divergence. Del dot j is equal to minus d rho v by dt. This is called as differential form of continuity equation. This is a differential form of continuity. This is called as differential form of continuity equation. The differential form of continuity equation, which states that the current or charge per second diverging from a small volume is equal to the time rate of decrease. This is indicated with this minus symbol, indicates that decrease of charge at every point. So this is your differential form of continuity equation and the above one is integral form of continuity equation. In the next class we are going to see the next topic.